Hello, fam. This is Zekaya from Mathatainment, reminding you that enthusiasm implies excellence. We are still dealing with our so called non routine exercises under Algebra Grade 12. The problem we are faced with is as follows: we are required to determine the maximum of s if s is equal to 6 all over x squared plus 2. You can see there that s is given in the form of a fraction where the numerator is fixed because it's 6, it's not changing, and the denominator is in the form of a function. By the way, the denominator is given in the form of a very special function which we may have learnt about in grade 11. That's a quadratic function, and it is commonly known as a parabola. That is a parabola. But before we come to that, let me emphasize something. When you want to maximize a fraction, that is equivalent to minimizing its denominator. The moment your denominator becomes very large, then your fraction becomes very small. And the moment your denominator becomes very small, the fraction itself becomes very large. For instance, let me give you this example here. Suppose I'm fixing a number here, 2, as a numerator, all over some changing number that I call n. I want us to realize something. Then here on my famous calculator, I have 2 divided by 1. Suppose I'm starting from 1. 2 over 1 is 2. Now, suppose I want to find 2 over 2, that is 1, which is definitely less than 2. And 2 over 3 is the same as 0.6, which is definitely less than the two previous values that we found. And 2 over 4 is the same as 0.5, which is less than any other values that we found before. So you can see that the moment your n becomes large, then the value of 2 over n becomes small because it's a fraction. And the moment your n becomes small, the value of your 2 over n becomes large. For instance, let's say you want to find 2 over 0.99999. You are getting something here. You are getting 2.0002. That is definitely larger than 2. And then, let's make your denominator to be smaller than this now. Let's say you have 0.05. So that we are getting 40. It's blowing up very fast. So now, coming to this problem, if we want to find the maximum of s, which is given as this fraction, let us try and find the minimum of its denominator instead. Let us try and find the minimum of the denominator, which is x squared plus 2. Let's try and find this. So now, since this looks like an expression in the form of a function that we probably saw in grade 11, it may be wise to say, let f at x to be equal to x squared plus 2. Okay, by the way, now we are in grade 12. Probably some of you already know what the minimum of this is. This function can easily be drawn as follows, by the way. Before we even come to the algebraic part of it, let us look at the drawing. This function is a parabola and it tends at 0 maps 2. It tends here. So now that you know that the minimum of this is 2, then it's easier to see what the maximum of this might be. But for those of you who may not know this, in grade 11, you may have learned that when you want to find the minimum of a function, that's equivalent to finding the coordinates of a turning point. In that case, you have x equal to negative b over 2a, where negative b itself is the coefficient of x, a is the coefficient of x squared, and c, if it's there, it would be the constant. So in this case, you can see that our negative b is like we are having a negative 0 because there is no x, all over 2 times. Your a is 1. So your x coordinate of the turning point is 0. After getting your that S coordinate, to find what the minimum is, that's when you want to find f at 0. Take this 0 and you substitute it straight to the original equation. So you are going to have 0 squared plus 2. And really, we are getting 2. So that's how we know that the minimum of f at x is equal to 2. Now that we know the minimum of f at x, and remember f at x is the denominator there, this is enough to confirm that the maximum of s, which is given by 6 over f at x, that is the same as 6 over the minimum, 6 over the minimum of f at x. And this is 6 over 2, and the maximum, ladies and gentlemen, is 3. That's how to find the maximum. The logic here is that whenever you want to find the maximum of a fraction, it is equivalent to finding the minimum of its denominator. Let's look at another problem. In this problem, you are also required to find the maximum here. We are required to find the maximum, and we are told that we have to show that the maximum of a square root of negative x squared plus 4x plus 12 is actually equal to 4. We're even given the answer here. We have to prove that the maximum of that quantity is 4. This is the function that you may recognize under this square root. It looks like the function that you probably saw before in grade 11. That function is still what we call a parabola. However, it may be a bit difficult to work with the square root. So let S to be this quantity under this everything with the square root is negative x squared plus 4x plus 12. Now, so that you will be able to work without the square root, let f at x to be equal to s squared. If you let f at x to be equal to x squared, then it means that your f at x will just be negative x squared plus 4x plus 12 without the square root now. Then you can work with this. From this, try and find the coordinates of the turning point. The y value of the coordinates of the turning point would be your maximum. It will be your maximum. So let us start. We have x equal to negative b over 2a. That is the same as negative 4 all over 2 times negative 1. And that is clearly 2. That's the x coordinates of the turning point. What about y? To find the y coordinates, that's when we're going to find f at 2. Finding f at 2, we are going to use our famous calculator and just do a perfect substitution there when we want to find f at 2. So let me shift the calculator slightly. Okay, yeah, still visible. So there we have negative into 2 squared plus 4 times 2 plus 12. We are getting 16. So we are getting, so 16 is our y value. 16 is our y value of the turning point. 16 is our y value of the turning point. So f at 2 is 16, and that's exactly our y value of the turning point. And this is precisely the maximum of what? This is the maximum of f at x. And remember, f at x is equal to s squared. So it's not yet the maximum of s, which is what we are required to find. It's not yet the maximum of s. Now that we have seen that the maximum of s squared is 16, check this, the maximum of s squared is 16, then this is enough to confirm that the maximum of s is just the square root of 16, which is 4. So we have managed to prove that the maximum of s is 4. But the trick that we used, we worked with s squared instead of s as it is, because we were avoiding working with the square root. Okay, so this is how finding a maximum is. This is how we find a maximum for various kind of expressions or equations. Thank you. I can't wait to meet you guys again in our next video. Thank you again.